So the first thing to do is to take this one apart. The GBAs, Game Boy Advances, have triwing screws on the outer shell, and then they have some Phillips or JIS screws internally. And you can buy a triwing screwdriver off Amazon or eBay for just $1 or $2, but the ones that they generally sell at that price range don't last very long. They're made out of some very mild, very poor steel, and they end up lasting maybe 1 or 2 repairs, and they go bad. So I do this a little bit. So I've actually upgraded to Moody tools. They actually sell. The first thing I wanted to buy from them is a type of screwdriver called a JIS, and you can see there it says JIS-S. And JIS is actually a Japanese standard that looks exactly like a Phillips head, but it's just a little bit different, and that little bit actually makes all the difference in the world. If the screws are JIS and you're trying to use a Phillips, what you'll end up finding is you'll end up with a lot more cam outs, and you'll end up with a lot more damage to your screwdriver or the screws. And really the only difference between a Phillips and a JIS is it's really subtle, but mainly the tip is not as pointy on the JIS. But the screws in most of these small game systems, anything that's made in Japan, Nikon cameras, but Nintendo, Wii, all of those screws are actually JIS, not Phillips. And when you use Phillips tools, you end up with lots of little problems. So I originally bought these. Moody's one of the only companies that sells good quality JIS bits in the United States that are relatively affordable. They're kind of expensive, but anyway, they also make a triwing, a couple different triwings. So I went ahead and bought. I've got some WIA bits, and I really like WIA, but they're really expensive. WIA does not make JIS drivers, so that's why I went with Moody on those. They do make, everybody makes a triwing nowadays, but anyway, I like these, and so I'm going to go ahead and take this shell apart now. Like I said, the outer shell is held together with triwings, so you definitely, if you're only going to do one or two of these, then definitely just get the $3 driver. But if you're going to do more than a couple, then you might look into upgrading. Okay, and actually this middle screw is a Phillips or a JIS. So it's got the 2 screws on top, and then the 4, and then finally the last one here. So it's a total of 1, 2, 3, 4, 5, 6 tri-wings, and then finally a Phillips or cross style one. You can actually unscrew all the screws and pick the shell straight up and leave the screws in, kind of set it off to the side, and you don't have to worry about keeping those in a bowl or something like that. So now that we've gotten the shell off, we can start taking things apart a little bit. The motherboard is held down by 2 Phillips head screws there, and I need to go ahead and pull the motherboard out. So pull off the side bumpers, pull out the shoulder buttons, and then also we need to disconnect the ribbon cable that goes to the screen. So just use a spudger or a screwdriver, flat bladed screwdriver, and just push the connector up until it clicks, and then also take out the power switch, and I'm going to go ahead and loosen up the 2 Phillips that hold the motherboard down. And now I will okay, and since I had already unclipped this, I didn't have to pull the ribbon cable out. I just tilted it up and it popped out. But so the buttons for the front and the screen are all on this side of the shell, and then there's this foam protective. You can just move that out of the way. If you turn it upside down, it'll all the buttons will fall out and you'll be sad. But so just be careful with that. There's actually some pads have gotten stuck to the side, so I'll just pull those and put them back. Okay, so I've got this Game Boy Advance motherboard, and this Game Boy Advance had an LR button. In this case, it's the L button, where the button's actually been broken. So zoom in there real quick so you can see that the actual little piece that goes in here is missing. So at some point it had broken off, and so I've got some buttons I pulled out of the donor system that I'm gonna be pulling parts off for this stuff. So the button I pulled off is right here. So in order to put this one on, I'm gonna take this button out, the bad button out, and then I'm gonna replace it with this one. And I've tried a couple different ways to remove these buttons, but so far the fastest and easiest one has been to use some hot air to heat up this side while I've got a hemostat clamped to the other side of the button, kind of pulling on it, giving it some gravitational pull. So the first thing though I'm going to do is to add some leaded solder to probably what's unleaded, and that will reduce the melting point of the solder a bit and make it easier to work with. So I get my iron hot here, and I'm gonna get out my probably 60/40. Actually, this is 63/37, but either way, just add some lead to the existing. Okay, so I've added quite a bit of solder, kind of the more the merrier, because what we're trying to do is get enough so we can get all of this. I've got 4 different pins I have to get all molten at once in order for this part to come out, and if adding a little bit more solder will actually help it keep the temperature, keep the heat in long enough so I can get all 4 pins molten at once. So I'm just going to take some hemostat and clamp it to the bottom here, and not too close to the not too close to the other side, because I don't want this to be too much of a heat sink, but I do need it to add some weight to the other side, so it'll give it a little bit of a pull. And then I'm going to get my hot air gun. I've got the WEP 858D hot air station. It's about $65 on Amazon. I find it's a really valuable tool for the money. It's very handy, very versatile. So I've got it set on 400 degrees, which is pretty hot, and I got to be a little careful not to burn anything up. It's a little bit messy way to do it. It's not pretty, but it seems to work pretty well. So you can see there's my button still attached to the hemostat, and I just gave it a little bit of a wiggle as I saw that the solder was starting to get molten, and it made a little splash mark here on my cutting mat. But no big deal, it scrapes right off. So the next step is going to be to clean up the solder that's still on the holes. They're covering the holes, so I won't be able to get the new part in until I clean that off. So I've got some solder wick. It's I like the MG Chemicals brand. It's got a lot of good flux embedded in the braid. If you use anything that's off-brand or buy off eBay direct from China. That stuff just doesn't work at all, and you're just kind of wasting your time and money. So if you've ever used some no-name wick and found it to be completely useless, that's why this wick is much better. I'm also going to add some extra flux, because let the flux out. So now I've got a ton of flux on there. I've got some really thick wick. I don't know if this is the thickest wick you can get, but it's thicker than usual. So I like to use it. And so I'm just going to put the wick on the pads and heat the wick up on top, and the solder should come up through. Okay, so I've still got some solder in this hole, and I flipped it over. It looks like there's actually enough on this side that I'm going to try to wick it from this side as well. Okay, so that seems like it's actually, I've got all the solder out of these two holes, but these two still have some solder that's stuck in there, and sometimes that works better than others. So instead of fighting with it, though, I'm gonna try a different approach. I'm gonna actually add some solder back, which seems counterproductive, but sometimes you have to have more to help you get at the stuff that's stuck in the middle of the holes. And I'm just going to get out my my desolder pump. This is a super, I just have a really super cheap one. Fail. I'm going to try adding some more solder to this hole, and then see if I can try wicking it again. And when in doubt, always more flux. Okay, and now those all four holes are clear. So now I'm going to clean that flux residue off, and then insert the new part. Okay, and as you can see now that the holes look pretty nice and shiny and clean, and not too much flux residue at all. So now we're ready to go ahead and try to insert the new part. So here's the button that I pulled out of another Game Boy Advance, and it had some solder and stuff still stuck on the legs. I've cleaned that up already with just using the wick. It looks pretty good. There's on the bottom of the button, there's a little black piece of plastic that serves as the spacer to keep it the right height on the board. I kind of want to make sure that I put this in as straight as possible. The alignment of the button in the console is actually pretty pretty important. They have some pretty close tolerances to get the buttons to feel right, you know. So I think that's pretty much it, though. That looks like it's in as good as it goes. So I'm just gonna flip that one over. I'm gonna add some more flux. Alright, and then I'm just gonna solder these 4 pins. And on this one I'm just using some pretty thick 0.032 this is MG Chemicals 6337. I don't use a lot of this thicker stuff. I have a big roll of really thin stuff, so this is one of the only brands I was able to find 6337 Eutectic solder in this gauge in smaller quantity. I didn't want to buy a big roll of it, but Amazon had this one. I would have normally I would get multi-core brand or Kester. I don't have any problems with this. It works just fine. But so that's the solder I'm using. That looks pretty good. Maybe not perfect. Maybe a little bit too much on this one, but it's not super critical. And as long as the solder joints are good and aren't going to be cold joints, it's not that critical. So there's the 2 buttons now. I'm just going to clean up my flux, and should be good to go. Okay, so I'll put this one back together and try it out, see how it works. Okay, so I've got this Game Boy put together with the replacement shoulder button, and I've just got an old Game Boy game in here, so I can use the left and right button on the Game Boy Advance to change the size of the screen, the stretch of the screen. So as you can see, that repair was successful. So there you go, changing out the shoulder button on a Game Boy Advance.